Whilst we're getting started, just a quick note that this doesn't cover all the stuff that's in the paper, and there are links to various things that are mentioned in here from the paper. Have I got a clicker? Is this the clicker? Yeah. I don't know if it's actually going to work. Let's see. Oh, yeah. So a couple of acknowledgements to start off with. The ideas in this, some of them came from, some of the most important ones came from Active Game Accessibility Project, which is mentioned in the paper. Also, Ian Hamilton provided quite a lot of input, as well as many people in the W3C's Accessible Platform Architectures group and its Research Questions subgroup. And I wouldn't be here without the Paciello Group supporting this and actually letting me come and talk to you about this stuff. Incidentally, if you need any accessibility audits or training or design reviews or anything, please let us know. Game accessibility is important because it brings significant human benefits. We are talking about access to culture, to recreation, socializing, education. All of these things are, games are big players in all of these areas. So we want to make sure that everybody is able to access games so that they aren't excluded from any of these things. The interesting thing about games is they are meant to be challenging. So there has to be some element of challenge in games. It can't be necessarily, it has to, if it's not challenging, it's not fun, that's what I'm trying to say. But the challenge varies from game to game. So the way that you make a game accessible varies from game to game. Let's talk about content accessibility first. Content is absolutely paramount. I mean, without content, a game is not a game. There are many things that you can do with respect to content. For example, you can use shape as well as color to impart important information. That's a very low-hanging fruit, and a lot of popular puzzle games do things like this. On the audio side, for example, you could use spatialized audio to help somebody who can't see very well realize where things are happening. But then there's also the possibility that people might not be able to hear very well. So for them, you might provide other things, which we'll move on to. But on the subject of accessibility for hearing-related impairments, Assassin's Creed Odyssey shipped with subtitles enabled. And the reason why it shipped with subtitles enabled is because the previous game, Assassin's Creed Origins, they didn't ship with subtitles enabled, and they found that 60% of the people turned them on. So they shipped the next one with subtitles, and 95% of people kept them on. So the 60% in the first place and the 95% kind of show some support there for things like subtitles. And then other games, such as The Division 2, 75% of people turned on subtitles at least once, and currently about 50% of people are using subtitles in that game. So that's quite a big thing. There's a link to the source of that information. I mentioned that you could use spatialized audio to indicate where things are coming from, but then again, if you struggle to hear that, you might benefit from a sort of visual indication of where that thing is coming from, whether it's damage or intrigue. This is an example of how that's being used. So there's, ironically, you may not be able to see it too well, but there's a bullseye on the red telephone box there, and that's from Everybody's Gone to the Rapture. And this is an example from the Game Accessibility Guidelines website of good practice. And if you look at the best practice section of this website, you will find lots and lots of examples, really good motivating examples of how to do things right. So the Game Accessibility Guidelines are very important. I strongly recommend you go and have a look at those. Also, accessible player experience, W3C's got several specifications that might help when considering things like how to make general software accessible, and also media related stuff accessible. So there's some guidelines there that are worth checking out. One of the things mentioned in the paper was that this is a game called Railway Hero, and just using the provision of content of different types, they were able to provide an experience which is really quite accessible. It's got a self-voicing user interface, so it talks for itself. It's accessible in high contrast mode. It's got lots of other options. These are some of the options that it has, but there's an elephant in the room, which is that lots of users with disabilities, lots of people with disabilities already have their own assistive technologies that they'd quite like to use to access this sort of thing at their own pace. Now, it's amazing what you can achieve just with content alone these days, but if you wanted to provide a sort of equivalent experience to what somebody might get using their own technology they're comfortable with, you would probably have to record audio for every user interface element in different languages, because the user might be from another country, and at different speeds, because different people prefer reading things at different speeds. And you'd also have to make sure that it works with a keyboard and a mouse and a game controller and a single switch. But if you supported certain APIs, a lot of that support would come for free through the user's assistive technology. So users need to be able to perceive the content and access the interface using the technologies that they've got set up that they want to use. So how do we integrate with existing assistive technologies? Here's some examples of such technologies. You've got screen readers, which read out what's on the screen, magnifiers, hardware zoom on a mobile device. Text transcription services are something that's come in recently. You might just have a larger screen, or you might have a controller that you've plugged in. You might have set high contrast mode in Windows, or just a larger text size in the operating system. Or you might even have variable game parameters like difficulty level or time required to complete certain actions. There's a picture of some accessible controllers. You've seen other examples in the previous talk, of course. So an interesting thing about these, if I just get back for a second, an interesting thing about these is I've tried to order them in a sort of top-down sense. So the top ones are really big, invasive assistive technologies, and the bottom one is just something that you could fine-tune at any moment. So you can vary the game parameters or just recognize the things that the user's changed in the OS. That would be a really good, easy thing, simple thing to do. But all of these adaptations, there's a scale of them for different levels of impairment, and also they can be implemented at different levels of, say, the platform, the engine, or maybe a specific game, depending on how you're implementing them. So user interface accessibility. This is a problem that has been solved quite well in the sort of standard operating system and native app sense. You have an operating system and you have an app running on top of it, and in between you have an assistive technology support layer, and then some assistive technology that queries that for information and presents it to the user in a way that they can understand it. On the web, it's the same. You've got a browser. There's an accessibility tree, which is a sort of accessible accessibility information associated with the DOM that your access technology can query and get out that information for you. And then on top of that, you've got the web app or the game. But and things like this, this is a screen grab of Google Wave. It's a complex application, but you can make things like this accessible by doing things like using the right HTML elements for things like buttons and links, highlighting the main region of content on the page and others. This is just a very quick example. If you haven't used the right elements though, because you've got custom ones, in the web world, you can do things like use any old element and just supply this appropriate semantic information through things like the role attribute, which is part of the accessibility specs on the web. But we don't have a way to provide that information when there is no DOM, when it's just a rendered image, for example. So that's a big question that we're facing. So assistive technologies can interpret that content, and they can pick up on those cues, and they can present them to the user, but we need a bridge between the web games that maybe weren't created with the web in consideration, maybe compiled to WASM or just generally render things pictorially, and uses assistive technologies. One more example, authoring tools. It's really, really important for people to get access to creating things as well as just consuming them. They're both important, and authoring tools is not necessarily getting as much of a airtime. So just a quick example on authoring tools and different ways of representing problems, which is similar to what previous talk was mentioning. You can represent things in different ways to make them more accessible. So if you were doing some very simple level design, you might use a sort of graphical CAD-like interface to design a map for a 3D game. But some time ago, I actually worked on a prototype proof of concept tool that allowed you to describe it using XML, because XML was really cool in 2008. It'd probably be JSON now, but you could convert it quite easily. So that same graphic that I just showed you of the CAD screen, this is how you might express it as an XML file, and it pops out, and you get this map for Quake. And blind people have been able to make some very rudimentary, because my geometry is terrible, maps using this sort of system. And we were kind of hoping at the time that somebody would pick it up and apply the same sort of technique to a newer engine. Anyway, some suggested outputs from this discussion, just a few from the paper that we mentioned. So we'd like to figure out how we can build that bridge between the semantics that are needed for assistive technologies to understand user interfaces. I think there are some big clues on that earlier today, which is very exciting. I mean, I've learned loads today. It's been brilliant. Also, can we find or think of some adaptations, low-hanging fruit that we might be able to do at the OS level or the game engine level or the game level? What would be some requirements for a framework to bring in adaptations for a user as appropriate, and recognize personalization that they've performed? How could we improve the specs that we talked about just before to make them more suitable for games? Or are they already suitable? Is there something that they're already doing that's helpful? And how can we think about how to make authoring situations more accessible? One thing that I was wondering about that authoring the tool stuff is if you make a machine-readable description of a level, maybe the machine can then make its own levels more easily. So maybe in response to things that the players do. So there's other ways that accessibility might be of interest, and in desktop apps, it's often used as a means to do user interface testing and things due to the automation that it affords you. So you can test all your interface out quite effectively with it. Anyway, some suggestions for outputs, and I had some questions for discussion that were just the ones that were listed in the paper. But what we'll do now is we'll just open it up for questions on both of the talks. So thank you very much for your attention.